Geometry is a subject that is often avoided or ignored or just plain skipped in elementary school years. Sometimes it's taught more in the primary grades where students actually work with shapes and things are more hands-on. But often when we get to the intermediate grades in elementary school or middle school, there's so much else to do that geometry might get slighted a bit. And I think the foundation for teaching geometry in the elementary and middle school years is very important, so students are prepared with the basics before they move into high school math. But more important than that, geometry is in the world around them, and they need to see that. What would you have students do, or how would you explain to students why there are 180 degrees in a triangle and 360 degrees in a quadrilateral? What kind of thinking and explanations might you expect students to say to you, and how would you model this back to them? Pause the video as you think about and complete that, and then see if your thinking aligns with mine. We would want students to do this, of course, in an activity so they can see it. We would have them all draw a triangle, maybe all different kinds of a triangle. We would have them cut out the triangle, and then we would have them cut off the angles in their triangle, the corners, and number those, just to make it easier to work with, and then put them on a straight line to see what would happen. So if I put the angles from this figure on this straight line, it might look something like this. This might be angle 1, this might be angle 2, and this might be angle 3. And of course these are not exact, but you get the idea. So if I put them on that straight line and have students glue them together, butting up against each other like this, they're going to discover that every single triangle, no matter what shape it is, no matter what size those angles are, every single triangle's angles are going to sit on that straight line. So that means a straight line having 180 degrees is what's created by those three angles, which is why there are 180 degrees in every triangle, no matter what the shape. We can do the same thing with a quadrilateral. So if we ask students to draw these, and they can all draw any kind they want, any four-sided figure that they want, and we have them do the same thing. We ask them to cut out their figure, cut off the angles, and put the angles on a straight line. So for example, with this one, which has 4 right angles, it would look like this. Angle 1, angle 2, we'd have to keep going around, angle 3, angle 4. And what they will see is that their angles go all the way around. So if we start here with this point on our line, we go this way, 180 degrees, we keep going, another 180 degrees, it's going to make 360 degrees. And that's going to happen no matter what the angles are like. That would also happen if we did that with the angles in this shape. So students can discover that every triangle has 180 degrees and every quadrilateral has 360 degrees. Having students do this means that it's going to stay in their memory. And we want them to be able to explain this in their language, in kid language first, and then add the mathematical language. What kind of language and pictures would you use to explain to students how to find the total number of degrees in a polygon? Or what would you expect them to draw and say when they explain their understanding to you? Pause the video and use drawings and words to model this. Using what we learned in the last slide, we know that every triangle has 180 degrees and every quadrilateral has 360 degrees. So looking at this polygon, we can draw a line here, or we can draw a line here, and of course you could do these lines in very different ways. And now I know that I have 180 degrees in this triangle, 180 degrees in this triangle, and 360 degrees in this quadrilateral. So I can add those up and find the degrees. Now the formula for finding the degrees in a polygon is slightly different. It is S standing for sides, the number of sides in the polygon, minus 2 times 180 degrees. Now why does that work? If we look back at our figure, what we would need to do if we're using the formula is have all of one thing. So here, the way we have it done now, which is perfectly fine, We have triangles and quadrilaterals, but formulas generalize things. So in a formula, we'd have to have things all the same. So what I might do is I might add one more line here so that I have all triangles. Because if I have all triangles, all the same thing, then the formula will work. So now I look at my formula and I look at my drawing. I have 180 degrees here, 180 degrees here, 180 degrees here, and 180 degrees here. So I would take 180 degrees times 4 because I have 4 triangles. How many sides were there in my figure when I started? 1, 2, 3, 4, 5, 6. There were 6 sides. Take away 2, that gives me 4, times 180 degrees. So why does this work? It's just a mathematical law of nature, that if you make interior triangles in a polygon, you are always going to have 2 fewer triangles than there are sides. That's just the way math works in the world. And somebody has figured that out and created this formula. The nice thing about having students do an activity and making sure that they can draw and explain this using this kind of language is that if they forget this formula, they can probably still figure it out. Once they do it, it will stay in their memory and they'll understand that this is all about relationships, not just a bunch of letters and numbers that they have to remember in a particular order that have no meaning. What are the basic shapes that are two-dimensional that we would want our students to know? And how would we explain to them what they are, what they're called, and what they look like? Pause the video and draw those using language that you might use to model to students. There's a lot here to think about, so I will give just the basics and you might decide there are more things that should be explained and drawn. I think one thing we want students to know right off the bat are word roots. For example, what does tri mean? What does quad mean? What does penta mean? What does hexa mean? Octa, etc., etc., etc. So we want to make sure that they understand those because those are commonly used in geometry, but also in other places in the world, and we can associate that. So that's very important. Of course, we want them to know what a triangle is, that it has 3 sides, and probably we want them to know the kinds of triangles. An equilateral triangle, an isosceles triangle, a scalene triangle, and maybe the basics of those words. Isosceles, is there a way to help them remember that? Scalene. Sometimes we can even use little tricks to help them remember that. We want them to know a quadrilateral has 4 sides. Any 4-sided closed figure will be a quadrilateral. So a square, a rectangle, a parallelogram, a trapezoid, all these are quadrilaterals. There are regular shapes and irregular shapes. There are sides that are the same and sides that are not. We want them to understand that this is a very general term, and within that general term, quadrilateral, there are more specific things like square, rectangle, parallelogram, trapezoid. We also want them to know the names of some other shapes. So a pentagon, 5 sides. We can talk about a regular pentagon and an irregular pentagon. We can talk about that same thing with things with more sides. Hexa, octa, deca, all the different kinds of shapes that use those key words. We probably also want to include some round shapes at the basic level. So circle, oval, some of those general terms, so that students are familiar with them. We also want to explain that these are 2-dimensional objects because we can measure them 2 ways. We can measure them by length and width. So we can go this way, we can go this way, we can measure 2 different directions, but they're flat, so that makes them 2-dimensional. We also want to relate the characteristics of shapes one to another. For example, if I have a rhombus, I can have students compare that rhombus to a square. How is it similar? How is it different? We can talk about the fact that we're basically pushing over the square to create the rhombus. So is a rhombus a square? No, because a square has to have right angles. But is the square a rhombus? And the answer is yes, because a rhombus has 4 equal sides, 1, 2, 3, 4, and 2 sets of parallel sides. So both of these figures meet the criteria for a rhombus. But this one is not a square because a square has to have right angles and it doesn't. So we want to make sure as we're teaching these two-dimensional shapes that we're relating those characteristics. A square, for example, is a quadrilateral. It is a rectangle. It is a square. It is a rhombus. Some characteristics are very general, some are more specific, and we want students to understand that. What three-dimensional shapes do you think students should know, and what do you think they should know about them? Pause the video as you think about this, drawing the shapes and using words to explain what you think is important for students to know. I think a nice way to do this is to start with the two-dimensional shapes and go from there. For example, we have a square. If we make a square three-dimensional, then we have a cube. We have a rectangle. If we make a rectangle three-dimensional, we have a rectangular prism. We have a triangle. If we make a triangle three-dimensional, we can have a pyramid. We have a circle. If we make a circle three-dimensional, we have a sphere. We can also use that circle as a base and make a cone out of it. We could also use that circle as a base or as a top and make a cylinder out of it. A cylinder could also have an oval as its top or bottom. We could make a cylinder that way. So relating two-dimensional and three-dimensional objects is good for students. They can also understand and see that three-dimensional means we have three ways of measuring. When we had two-dimensional objects, we could measure length and width or base and height or whatever words we want to use. We can measure it two different ways. They're flat. Three-dimensional objects can be measured three ways. We still have the length and the width or the base and the height, but now we have an extra dimension. So we can say this and this and this. So we add that depth, which makes it three-dimensional, not flat. There are some important words in geometry that I think should be introduced, and here are two of them. How would you explain these two words to your students? Hopefully you would have them work with real objects first, but when you get to the point where you're drawing and explaining, what would you say? Pause the video and see what you think. Congruent means that two shapes are exactly the same. They have the same shape, the sides are the same length, the angles are the same, everything about them is the same, except they can be in a different position. So for example, if I make a triangle this way, and I make a triangle this way, and if I pick this one up, and I turn it and flip it or do whatever I need to, and put it on top of this one, if they're exactly the same, they are congruent. If they aren't, then they're not. Similar is similar. Similar is a word that means something a little different in math than it does in the real world, so we need to make sure that we teach that well. If I have, for example, this triangle, and I have this triangle, and if my measurements in this above triangle are 3, 4, and 5, let's say that's inches, then the triangle that I have here, if it is similar, will have a direct proportion to that triangle. So for example, my measurements here might be this, this, and this. So if these relationships are the same, 1.5 to 3 is the same as 2 to 4 is the same as 2.5 to 5, that means these triangles are similar. They are basically exactly the same, except one is shrunk or one is enlarged, but they have the same ratio. They'll have the same angles and the same ratio to their sides. What do the words reflection and rotation have to do with geometry, and what basic foundational knowledge do we want students to have about these? Pause the video and see if you can think about what kinds of words, explanations, and drawings you might want to use to model this to students and have them model back to you. Reflection means that we have a mirror image. It's like a flip over a line. Students can understand reflection, and we can actually teach it by having them work with mirrors. So like, for example, if we look at these two shapes, the lines are not straight, let's pretend they are. If I put a line right here, then this image is a mirror image of this image. So it's a flip over a center line. It's like taking an actual figure and flipping it. Of course, the best way to teach this is to give students actual shapes. They can trace the shape, then they can flip the shape, and they can see what that reflection looks like. We can also use mirrors and shapes to do this as well. If we look at this set of shapes, we have, again, a flip. The shapes are the exact same, but they are flipped over a center line. So if we make a point here, draw a line, if I took this shape and flipped it over, it would be that shape. That's a reflection. Rotating, on the other hand, means turning a shape around a point. So for example, let's just say that I could start here and I could keep this point right where it is, leave this corner right here, but I could move this shape so that it went this way, or move it so it went this way. That would be rotating the shape. It's valuable for us to teach these words to students by connecting them to things in the real world. For example, we can talk about a mirror image. We can talk about reflection in a mirror. We can talk about things in the real world that rotate. We can talk about how the earth rotates on its axis. So we can connect these words from math to other subject areas and to other things that students see in the world. That's valuable. How would you explain symmetry to students? What would you say and what might you draw to model this for them? And what would you want them to be able to say and draw to model it back to you? Pause the video and see what you think. There are a few different kinds of symmetry that we can teach students. We have symmetry that is like reflection, which we just talked about, that mirror image. We also have rotational symmetry. We also have point symmetry. So symmetry is when one shape is just like another shape if you flip it, slide it, or turn it. Talking about symmetry at a basic level, I think, is good and enough at the elementary level. For example, if this were a perfect heart, we can draw lines and create two sides that are exactly the same. So if I draw a line here, this side would be exactly the same as this side, which means this would be a line of symmetry. What about in a circle? Where could we draw a line that would be a line of symmetry here? We draw a line and it's exactly the same on both sides. Well, we could draw it here, or we could draw it here, or we could draw it here. It's kind of fun for students to think about the fact that a circle has an infinite number of lines of symmetry, whereas in this heart shape, it has only one. Because if we drew a line in the heart this way, the two sides are not the same. The only place we can draw it is here. Symmetry. Two shapes that are exactly the same if you flip, slide, or turn it. A nice way to have students learn symmetry is by folding. If they have shapes and they can fold them in different ways, then they can discover where those lines of symmetry are. That's a nice hands-on way to teach this concept. Geometry is a subject that elementary students often enjoy. They enjoy it because they can work with real shapes. It's visual. They can draw. It's something that can make math meaning very clear because they can see the math. And that's what we're all about as we teach conceptual understanding in math.